అదే వస్తుందో కనుక్కోమనాలి. Good morning, dear students. For the gate class today, we are going to discuss again the statics part. Basically, buses, frames, and internal forcing structures. That means most of the structures which we are reading in a civil engineering or a mechanical engineering is in the form of a bar or a truss or a frame, or it can be a plate or it can be a shell, like that we can consider. These are the more like pressure vessels, heat exchanger, mechanical engineering, civil pressure. See, these are the pipelines, civil engineering construction, like shell structures. See, these are the structures generally which we classified as one-dimensional, two-dimensional, and three-dimensional, which we already mentioned. When we are discussing a dimension problem, always it is connected with the degrees of freedom of the system. Let us today, if we can see the syllabus once again. The internal forcing structures, that is the civil engineering title, and whereas the mechanical engineering is the trusses and frames. Both are same. That is the topic which we are going to cover today for the 4th class, engineering mechanics. Now, what are the learning outcomes from these titles we are going to get today? What we are going to cover and what we are going to discuss regarding trusses and frames. Here, we try to represent or express what are the internal force in the structures. That is, a member is what type of force it is subjected, whether it is a tensile or a compressive or other forces, if it is a frame. Then, truss and frame we will try to discuss. There is a plate and shell, other things are not there in this particular subject. Sometimes truss in some condition we will consider the bar also. Then recognize and apply the concepts of method of joints. These are the 3 methods what we are using: method of joints, method of sections, and the graphical methods. Then the relation between the forces. When we are applying external forces, what is the relation which we are considering? How to get the unknown, the internal force in the members. See, apply all these concepts to trusses and frames today. You have to understand the concept. Then it is no problem whether it is a gate or UPSC, whatever. The concept should be clear, and update the knowledge from time to time and apply the physical system. This is what are the learning outcomes we are going to get from today's class. So now let us see few fundamentals regarding trusses and frames. Truss is nothing but a pin-jointed frame, is a structure made of slender, different cross-sectional dimensional members. Any cross-section, the choice is yours. But here the fundamental principle is the dimension of cross-section should be very, very small as compared to the length of the structure. That is what they pin connected at the ends and capable of taking loads at the joints only. If you can apply loads at the joints only, we consider the truss. Indirectly, other than the joints, if you can apply, it is called as a frame. That is a fundamental difference between the truss and frame. Then another difference is truss is always load acting in axial direction, frame is having load acting inclined to the axis. That is another thing. Because of inclination, if you can resolve the forces at any point of the structure, it is having a horizontal component and it is having a vertical component. That means vertical component is perpendicular to the axis, is the transverse direction. Horizontal is in the axial direction. That's why it is a perpendicular to the cross section is a beam definition. Beam is always defined as load is acting perpendicular to the axis. Bar is having always load is acting parallel to the axis. If you combine these two, you will get as a frame. The same bar in some condition, some orientation, we call as a truss. So these are the four structural members we will try to compare. Once again, I am defining bar, beam, truss and frame. Bar and truss are one family, beam and either a bar beam or a truss beam. You can consider any combination. Bar and truss are one-dimensional members. Beam and frames are two or three-dimensional members. If you want to consider bar in one dimension, two dimension, three dimension is possible. But in any dimension it is having 1 degree of freedom along the local axis. If you resolve a global axis, that is a different story. But as far as the degree of freedom is concerned, for each point, whatever the point you are considering a pin joint or something else, at each and every point of the joint, we have only 1 degree of freedom, that is the displacement in axial direction. Same member, if you can keep in x direction or y or z direction, it is a bar. Not only x, if you can consider, suppose a bar is subjected to A and B point. A point is 0 degrees and B point is, let us say, 180 degrees. Then the orientation change. If you are considering A point, the angle is 0. If you are considering a B point, the angle is 180. Whereas in case of bar, only with reference to origin, either x-axis, y-axis or z-axis. So this is the difference between a bar and truss. Both are one-dimensional, both are 1 degree of freedom system. You can consider 2-dimensional, you can consider 3-dimensional bar also. That is the resolving the forces, that's all. But the actual force is along the member, that force you can resolve in any number of directions. See, that is the definition of a bar and truss. Where beam and frame is, beam is subjected to load transverse direction, perpendicular to the axis. Earlier parallel to the axis, now it is a perpendicular to the axis. When the load is acting perpendicular to the axis, you have a shear force and bending moment, or a slope and deflection. Kinematic quantities are forced quantities like force and moment, or kinetic. See, now what we have to consider is, a beam is subjected to shear force and bending moment 2 degree of freedom. But a frame is a combination of a bar and a combination of a beam or a truss and beam like that. The truss structure is only one member only you can consider the frame when the load is acting other than the joints and inclination to the axis. See, this is how in one, say suppose if you can consider truss consists of number of frames. In one frame it is acting perpendicular to the axis. But with respect to other frame it may not be perpendicular. See, then the entire structure is a frame now. Like that we have to consider. I will explain with some of the figures you can clearly understand. See, that is the first part of the difference between a bar, beam, truss and frame. Other structural members are there, shell, pressure vessels, heat exchangers, spherical heads, different heads we can use. But those all are not there in our syllabus, we no need of at this point of time. Such members is used in the way we are using, in roof trusses to support roof, bridges and decks, support decks, in the underground to keep the decks rolling, etc. supports, and even buses, locomotives, aircrafts. These all, whatnot, everywhere it is there. Now the truss or a frame can be considered a planar or a spatial. A plane or a frame or a truss. A truss in which or a frame in which all members like a single plane is called a plane frame or a plane truss. Both the places definition is same. If it is in a single plane, it is a plane truss. The basic objective is to resist the forces acting on a plane of frame. Then space frame is if all the members of frame do not lie in a single plane, they are called the space frame. Like cell phone towers, tripod stands, transmission towers, power line, power transmission, heavy capacity towers. Like that, you can give a number of examples. See, this is what is the definition of a truss. A truss consists of straight members connecting at the joints. No member is a continuous through a joint, and it should be the triangular shape. Why? Because otherwise it is not stable. We will go through that part also. Always the truss 3 members should be connected in a triangular form. If you can connect 4 members, it is not stable. That we will discuss later. A truss carries only the loads at the joints only, which acts in its plane. It is a plane truss. All members are acting in a single plane. If bolted or welded connections are assumed to be pinned together. Even if it is bolted or welded, we are assuming the assumption is it is a pin joint. Even if it is rigidly, because it should be a resting member, it should not deform. That's what the meaning. That is the main objective. That's why we are considering engineering and mechanics problem. Otherwise, you can go to some other problem. It's a deformable body. Forces acting at the member ends reduced to a single force and no couple. Why? Because all at the pin joint all are intersecting. There is no question of any moment. Only the forces. So that's why in a concurrent system or a coplanar concurrent system, we have 3 equations. Sum of forces in x direction 0, sum of force in y direction 0, moments about a particular point 0. But moment equation here, the necessary sufficient condition, but you don't get any parameters in that. That is what is the meaning of it. That don't affect. But it has to satisfy. Only 2 force members, that is the tensile or compressive, the line of action coincides along the local axis, that is the geometrical axis of the member. That means it is a push or a pull, tension or a compression. And to pull the member apart, the external force or internal force, either tensile or compressive. It is an axial member basically. It may be increasing length or may be decreasing length. One is positive and another is negative. See, this is how we will define the truss. Here, this is the previous slide only. The trusses are used in other applications. If you can see the buildings, the bridges, towers, satellites. Satellites, the cantilever like solar cells and other things you can fix with the trusses only or a frame, depend upon the requirement, what type of loads you are resisting. Very long spans like satellite wings, such as in airport terminals, aircraft hangars, cranes, sports stadiums, stadium rooftops, auditoriums, and leisure building, whatnot. Everywhere these are the trusses which we are using. As compared with the slab, the weight of the truss is very low as compared with the slab construction. And you can easily, that means within less time you can complete the structure. Completion of a particular task is compared with the slab, it is very easy. The trusses are also used to carry heavy loads and are sometimes used as a transfer structures. I already defined a planar truss is one which are members and nodes lie within a two-dimensional plane, or what? Member is one-dimensional, but you can consider a two-dimensional, three-dimensional. That is what they mean. The space truss is anyway three-dimensional. There is no. It is a two-course member only. Once again, I am repeating that always you have to keep in mind. Why I am repeating some particular point number of times means you have to keep always, when you are applying external forces, there are internal forces in the member. In a case of a truss, there is always either tensile or compression. That's all. As for the truss is concerned. It typically consists of rafters, posts, structures, rooftop bridges, etc. Most maximum applications. If the truss is in equilibrium, at each joint must also be in equilibrium. That means, if you are assuming that the total stress is in equilibrium, because here we are using three methods: method of joints, method of sections, and graphical method, something like funicular polygon and other things. See, what is the meaning of this is, if it is in equilibrium, stress, total stress, even if you consider a particular joint also must be in equilibrium. That is what the meaning. In case of method of joints, this concept here is. In case of method of section, the third point, if the truss is in equilibrium, then whichever section you are considering, a particular part, the long trusses, etc., where we want to determine a particular member force, then no need of considering all the members and all this. In that case, we will go method of sections. In that case, if truss is in equilibrium, then whichever section of the left part, right part, whatever the part you are considering with respect to a particular member, that also must be equal. The entire section part is also equal. See, these are some of the things we have to keep in mind. Generally, the procedure starts in method of joints. Joint that has no more than two unknown forces at the supports. It can be in other place, it can be in any, but at the joint, if you are considering not why, because in the momentum equation there is no say anywhere. Any point of joint, if you are considering, you don't have sanctity of a, because all forces are intersecting at one point. Moment equation is not considering. See, that's why what we have to do is, we can consider 1 minute. నెరవేరింది అతను పడిపోయాడు మరి ఇప్పుడు ఎలా ఉంది ఏమంటే ఏమి ఆఫీస్ గవర్నమెంట్ వచ్చి మనకి పొద్దున లక్ష్యం లేదు ఒక్క కూడా అసలు ఎవరు గవర్నమెంట్ ఆర్డర్ ఇచ్చింది సీఎం ఆర్డర్ అంటే నేను వచ్చి హాస్టల్లో వెళ్ళాలి యాభై వాళ్ళు గవర్నమెంట్లో కూడా వెళ్ళాలి ఇప్పుడే 3 మంది ఉండాలి చాలా వర్క్ మన గవర్నమెంట్ డబ్బు హాస్టల్ ఉంది అది ఒక్కటే పోతుంది ఇది అడగండి చూడండి అంటే అడగ అంటే మీకు అదే అదే సిచ్యువేషన్ మన గవర్నమెంట్ రావడం మొదలైన ఇదే ప్రయత్నిస్తున్నారు మొన్న అబ్బాయి వస్తాడా అక్కడే కావాలంటే వాడు హాస్టల్లో కాబట్టి హాస్టల్ అరెస్ట్ చేయాలి Okay. Sorry, my dear students, there is urgent call. Now, the joints with external support always connect with the two truss members. Procedure starts with not more than two unknowns. That's your one should has to remember. At any joint, because you have three equations, some of the force in x direction 0, some of the force in y direction 0, moments at a particular point here. Moment, because all forces are intersecting at a particular point, there is no sanity of the moments. See here what we have to do is, the joints with external supports always connect with the two truss members. Each member only takes axial forces and all members are perfectly straight. This is one more thing you have to keep. Because curved members we can't consider here in the trusses. Only the straight members only, that is another assumption. If you want, you can, real scenario if you can get, but in our syllabus point of view, we'll try to consider like this. Now let us go to what are the assumptions which we are following. The members cannot develop moments at the ends. The members cannot develop moments at the ends. The members are always subjected to purely axial forces. Some of the things a little bit repetition, but please keep what are the things which are coming as an assumption before solving problem. Before solving problem, I am start with these are the assumptions. The member cannot develop moments at the ends. The members are subjected to only axial forces. The connections to other members are perfectly pinned. Even if they are welded or bolted, we are assuming that it is a pin or hinge. The frictionless joints, that we are neglecting the friction here. Each member of uniform cross section, straight member, only loaded at the joints. The entire structure is one plane. If it is in a plane truss, each member has no weight. Early weight of the member is neglected compared with the forces, sectional forces, internal stresses. The truss members are connected together at their ends by frictionless pins. The truss members are connected together at their ends by frictionless pins. So this is how generally we will try to consider the trusses. Now let us come to the frame. Frames are, if you can see the figure, not only the axial load, it is a perpendicular load. That means at each and every point, perpendicular load means you have a beam. Beam should have shear force and bending moment. Not only axial force, we have a bending moment, shear force, that means the total 3 degrees of freedom. We have 3 equations. That's why the previous truss structure as well as the frame structure, we are generally considering as a statically determined structure. We have 2 types of structures. 2 types of analogy. One is a statically determined, the other is statically indeterminate. A statically determined means I have not given a PowerPoint that combination. Statically determined means we have to, whatever the number of equilibrium equations are sufficient to solve the unknowns in the given problem, that type of structure is called the statically determined structure. Suppose here in a plane truss we have 3 equations. Some of the force x direction 0, some of the force y direction 0, some of the moment z is equal. If it is more than that, number of unknowns, let us 4, available equations are 3. Then 3 equations are not sufficient to get the unknowns. That is what is called the statically indeterminate structure. This is how statically determinate structure, statically indeterminate structure. It is a multi-force member, at least one of its individual member. There is even one member, suppose perpendicular, in another case it is an incline. With respect, if you have any connecting members. It can be a rotation or it can be a translation. Anything you can apply. Couple, there is force or a moment. Sometimes by applying moment also you have a shear force and bending moment. we will get. That is one type of load, that's all. External load. Due to that, what are the internal stresses? When you are applying a force perpendicular axis, when you are applying a moment along the particular member, a load or a distributed load or uniformly distributed, linearly varying load. Due to that, you have shear force and bending moment. See, that's why here the support loads, usually the frame consists of support loads, usually stationary, fully constrained. These are the cases, generally frames we are subject to, we will consider in detail later. Frames are structures which are designed to support applied loads and are usually fixed in a particular position. Not all forces are directed along the members as in the case of trusses. But here the forces are directed along in a member of a truss where force along the member, but in frame not like that. That is what but indirectly speaking, truss is having only, in a local axis I am talking, only 1 degree of freedom, frame is having 3 degrees of freedom, beam is having at each point 2 degrees of freedom, at point only, or at a particular particle, or a rigid point. If you are considering 2 nodes like in finite element analysis, each node is having 3 degrees of freedom in frame. Beam is having, each node is having 2 degrees of freedom. Truss is having, each node is having 1 degree of freedom. So that's why their stiffness matrix is, in case of bar, 2 nodes are there, it is 2 by 2. Because 1 degree of freedom at one node, 1 degree of freedom at second node. Like that, the degree of freedom, how many you are considering, but here at a single point, local axis stress is having 1 degree of freedom. If it is a planar stress, global axis 2 degree of freedom. That is the resolution of the force. Whereas the beam is having 2 degree of freedom, frame is having 3 degrees of freedom at a particular point of view. Now the lower part is same, but upper part, if you can see a truss is a structure composed of rod members arranged in the form of 1 or more triangles. A frame, on the other hand, is a structure that consists of arbitrary oriented beam members which are connected rigidly or by pin or joint. The members supported by bending as well as action. That's what the meaning. In the figure, it is given as, see here, the bending. Due to this, the shear force, and that is what is the meaning of the bending and action loads. Bending. Due to this, whether the force or a couple or a distributed load, uniform distributed load, that is what we will consider. See, this is an example. Here it can be a force, it can be a couple, or it can be a moment, or it can be UDL, or it can be linearly varying load, or it can be quadratically varying load, or cubically varying load, etc. So this is what is consists of, we are calling as a frame. Okay. See, this is what is the truss. Truss is loads always at the joint C, whereas frame is anywhere you can apply. This is the difference between the basic difference between the truss and the frame. If you are considering this member, it is a bar, because I am assuming it is an x-axis. It is y-axis. If you are considering this with respect to x-axis, 0 degrees. Here this point, this is x-axis with respect to this member, because 0 you have taken as a, let us say counterclockwise direction, 0. But this axis and your reference axis coincide. When you are taking this point, this is an axis and this is the angle, 180 degrees. Like that orientation, if you are considering the same bar, you can consider as a truss member. If you are considering this, it is 60 degrees orientation. If you are considering this, again come in a counterclockwise, it is 300 with respect to horizontal, 180 plus 60, 240. Like that, with reference to a point, it is changing the orientation. That if you are considered, that is a truss. Otherwise, it is a, if it is only the XYZ, it is a bar. But see, the forces are at the joints, members are the same cross section, there is no straight, it should be a straight, loads always apply at the joints. Any members can be connected, but if I want to consider this joint or this joint or this joint, Maximum you can see that only it should have two unknowns. Such a way you have to go one by one. One joint, second, third, fourth. That is what the method of joints really. Whereas method of sections, I need only the force, internal force along this member, I don't want. Now you take any one section here. If the truss is an equilibrium, when I am taking a section here, this part is also must and should be an equilibrium. When the truss is an equilibrium, if I can take this joint, the joint is also an equilibrium. See, this is how generally we try to consider the difference between the truss and frame. Instead of distributed load, let us say only load, concentrated load or point load. That is also frame. Only loads, external loads, what we are applying. That is the only change. Even in place of that, you can see the moment also. Or here you can apply load inclined. So this is what is the another important the difference between the truss and the frame. Now see the stable part in case of trusses, stress stability. If you take it always a triangular member due to application of load, only the difference between this and this is this member is not there. This member. Because of that, what is happening is these always in a rigid form, it will only resist external forces. That's why more strength. But whereas here, if you can see, I am joining this also to increase the some more. Even then, further strength is increased. All are triangles. Earlier also triangle. See now, so let us suppose this is not a truss member. See that shape, how it is changed. It is something like unstable. Or suppose let us say even a thin member is not there. Let us assume it is not there. Then the shape of this, it will change due to application of load, some other will change. Okay, then it is called the redundant stress. Sometimes more like that. More if we can use this and this, it is a redundant stress. Again, 1 minute. Hello? Hello? Morning. Seven. మూడు ఫైళ్ళు హార్డ్ కాపీ సాఫ్ట్ కాపీ ఒకటే మ్యాటర్. అది నేను పెట్టి దాన్ని బట్టి మనం ఏదైనా పాయింట్ ఇచ్చాం కదా. దానికి టేబుల్ సపోర్ట్ ఈ లెటర్ సారథ్యం లెటర్ ఒక టేబుల్ ఇచ్చాను కదా సింగిల్ పేజ్. డాక్టర్ మీకు వాట్సాప్ పెట్టాను అది కూడా. అది ఇవ్వాలా సైన్ చేసి? పెట్టేస్తాను. అలా అలాగేనండి, పంపించు. ఓకే, అలాగా. Okay, now this is what is called the stability or stable or unstable. Truss stability and redundancy. That means if I can connect one more member, this is one member, this is another member also. It is not required even if it is a more rigid, but that is what is the redundant structure. If it is not there, the shape is changing. That is unstable. Sometimes stable structure, unstable, sometimes redundant. Even if not required, you are using more members. See, that is what is these are the things generally we come across, we try to avoid. That can be determined by using the equation. A joint is always considering allow only fx0, fx, that's why 2j minus 3 is number of reactions. A triangular frame is a simple perfect frame, it has 3 joints and 3 members, that's all. A pin jointed frame has got sufficient number of members, just now I defined. If 3 members forming in a, that is what is called the perfect truss. Otherwise, something like unstable structures, redundant structures. Suppose if you are considering a 3-dimensional truss, here I will show. These are the some of the truss shapes. Will come to this point. Let us consider this is the truss. Okay. Now this is one joint, this is the second joint, this is the third joint. 3 joints, 3 members. Now if you can substitute in 2j minus 3, joints are 3, reactions are, because it is a roller support, it is a in support. Roller support consists of only vertical reaction. In support allow rotational degree of frame, translation x, translation y. Here this is the allowed translation as well as rotation, that's why only vertical unknown, total 3 unknowns. That's why reactions are 3. Joints are 3. Now if we can go to the equation, this joints are 3. 2 into 3, 6 minus 3, it is 3 members. That is a perfect truss. If left hand side is equal to the right hand side. Left hand side members consist of 3, right hand side. Now let us go to the previous figure. Suppose I am taking this member is not there, I am taking these 4. Joints are 1, 2, 3, 4 joints. And reactions are again, let us say 3 reactions. This is anyway triangle stable, this is stable. I am considering the central part. Let us assume this joint here, or otherwise I am removing this part. Now the 4 members are there, 4 joints. If you substitute here, 2 into 4, 8 minus 3, 5. Members should be 5. But here, members are, I already said it, I assume it is not there, 4 members. This is what is called the unstable. If we can substitute this, 5 members. Or if I can add one more like this, 6 members but 4 joints, I am getting 5, that is a redundant stress. See, this is how from that equation we can determine that is the left hand side may be less than right hand side, or left hand side may be greater than right hand side. This is how we will consider a perfect frame or a deficient frame or a redundant frame. Frames can be one many अभी मैक्सिमम एस्टिमेट्स है अपन 2017 का गवर्नमेंट एस्टिमेट्स अंतर ఈ పరిపాలన రెగ్యులేషన్ తీవ్రమైన రీసెర్చ్ ఇప్పుడు గవర్నమెంట్ 1 year గవర్నమెంట్ కాన్సెప్ట్ చేయడం ప్రాసెస్ Extreme accident during this government time also. Okay, sorry, this. See now here, left hand side is greater than right hand side, redundant frame. That's why what I mentioned. It can be a deficient or imperfect frame, or these two are imperfect nature. But the perfect frame is left hand side is equal to the right hand side. That is m is equal to 2j minus 3. See now these are the assumptions I already mentioned, but main assumptions are pin jointed, load sector the joints, self weight is negligible. As for when you are applying a method of analysis, others also there, but it's by default coming, but these are the things you have to take care about. What are the methods of analysis which we are using to solve your problems? It can be a method of joints, or it can be a method of sections, or it can be a graphical method. That is molecular, polygon, etc. These are the three methods what we are considering to analyze the stresses depend upon the convenience of the problem. If I want to consider the stress in the stress that is internal force in each member, it is method of joints is better. If I want to a particular member stress is required, use the method of sections. Where lengthy structures are there, I need only few members. In that case, no need of joint by joint, it will take laborious time and also cumbersome. In that case, you go method of sections. A graphical method sometimes it is very easy to determine the stresses, internal forces. That is where we can use a funicular polygon. These are the different cases where the nomenclature and other things, different that is different classification. These all are not necessary from names and other things for competitive examination point of view, but where we are using these stresses, what are the shapes we are using, etc. See here, if you can see, the curved is also there. But in our analysis, we are assuming as a straight. See here. But most of the application, it is a straight members, each member. The shape is your choice. So these are some of the other truss shapes. And the bridges, different bridges where we are using a trusses. So now let us consider a simple example method of joints. You have to select any joint. Suppose I am taking this joint. It consists of horizontal reaction, vertical reaction. That means this is something like a hinge joint. This is a roller joint and it is a hinge joint. I am taking this part. This is horizontal because a hinge joint is only allow the rotation, it won't allow translation in x direction and y direction. Vertical reaction and horizontal reaction. It is only the vertical reaction. Total say 3 unknown, 3 equations. That's why it is statically determined. Other internal force we have to determine. But as for when you are applying external loads, there are 2 supports. I am applying loads at the joints like this, the external loads. When you are applying external load, what are the support reactions? These are the supports. These are the supports. In that case, one is a hinge and another is a roller. Roller is having a vertical reaction. Hinge is having horizontal and vertical. And this is how we will try to consider the process. The force along the members. In this case, sigma fx 0, because moment all forces are intersecting at a common point, even take any moment, it is always 0, any point. So that's why here, 2 unknowns, horizontal and vertical, 2 unknowns, 2 equations. But as a truss, if you can consider, then there is a validated momentum equation. If I can take moment point here, force into distance. If I can take moment about this point, force into distance. Sigma fx 0, fy 0, moment 0. 3 equations, 3 unknowns. That is what is the statically determined. Otherwise indeterminate. We can create indeterminates also. We can create with any plane structure and other things. But generally, if the number of equations are sufficient to solve your problem, number of unknowns, that type of structure we call it the statically determined structure. Rigid body equilibrium. This already, I think in the second class we have discussed. The support can be a roller support. Roller means, see, it is rolling like this and translating. That means it is allowing 2 degrees of freedom. Maximum 3 degrees of freedom. It is a 2-dimensional planar. Out of 3, how many I am getting? I am getting rotation of this roller and translation. Unknown is vertical reaction. That's why F. A hinge joint is only rotation allowing. No translation. It is fixed C. That's why vertical reaction and horizontal reaction. Vertical and unknown ones. If you consider fixed support, it is a horizontal reaction, vertical reaction and moment. See, that's why when you are taking this kind of joint, it is having two translations and one rotation. And whereas in other case, it is a vertical reaction, here horizontal and vertical. That's what, this also we have discussed earlier, only recollect. First alternative is always better in this case. There are the other four systems in second and third alternative, but here the first alternative is sufficient. If you are considering method of joints, only possible equations are sufficient. If you take method of sections and reaction forces, all three equations are required. Okay, this is how generally we will try to consider. Now let us take the simple how the loads can be applied. Load is like a concentrated load. This is a, if this load is not there, if this load is not there, if this load is not there, then it is a truss. But if you are considering this load in addition, see, our assumption is load at the joints. This is valid. But other than the loads, apply a joint. See, this is a perpendicular axis, but this is a, with respect to this, it is inclined. With respect to this, it is not inclined. It is some inclination. With respect to local axis, it is perpendicular. With respect to local axis, it is perpendicular. But as a truss whole, that's why it is having a loads other than the joints. It can be loaded, it can be distributed, it can be moment also. Okay. See, this is how the difference between, this is again a truss, loads applying at the joints. Statically dependent truss. And this is a, as per the loads, external loads are concerned, it is a frame. It is a truss and it is a frame. These all are, only I am defining, considering a perfect truss. This is a perfect truss. Why? Because if you take the joints 1, 2, 3 and members also, it will satisfy. Suppose if you take entire stacks, why I am calling it a perfect truss? J is a number of joint, R is a reactions. Here how many reactions? Is a roller joint, only one vertical reaction. Just now I defined. This is a roller joint, vertical reaction. This is the hinge joint, two reactions. This is a roller joint, one vertical reaction. Hinge joint, two reactions. Total 3. R is 3. Number of joints 1, 2, 3, 4, 5. 2 into 5, 10, 10 minus 3, 7. Right hand side 7. Let us see the left hand side. 1, 2, 3, 4, 5, 6, 7. That's why it's a perfect truss. This is also a perfect. 1, 2, 3. 3. 2 into 3, 6. Reactions are assumed it is a roller, it is a hinge. Because hinge is this should be fixed at one place. If this is also a roller, so the entire system is moving. That is what the meaning here. 2 into joints are 3, 2 into 3 6, reactions are 3, 6 minus 3, 3. Right hand side is 3, left hand side 1, 2, 3, 3 members. See, that is how we will consider the type of member, tensile or a compressor. Okay, this is how we will consider. Now let us consider a simple truss. This is a perfect truss. We got 3 joints, 3 reactions and 3 members. 2J, J3, 2 into J, 2 into 3, 6 minus reactions 3, 6 minus 3, the 3 members. Now what is the problem is, as a entire structure, these are the 2 reactions. Horizontal there is a reaction, but no other effect here. That's why that is 0. Only vertical 1000. You find out the reactions RA and RB by using simple principles. This is what RA and RB. Is a symmetric load. The load should be shared equally. That's why it is 500 and 500. RA and RB. Now I am applying a method of joints. Let us consider this joint. A consists of the internal force along this member, internal force along this. This you can consider towards joint or away from joint. You start with some assumption. There is no problem. If you suppose if you are like this, if you are getting a negative sign, then you can that is the later will decide. Suppose let us say I am considering like this. Somebody, if you want, you can consider towards this direction also. That is your choice. Similarly, FAB is this. That is I am considering away from the joint. This is towards the joint. Or you can consider this away from the joint. This is towards the choice is yours. Then this is the reaction. This FAC now resolve two components. FAC sin 30, FAC cos 30. That is what is the. Now this is the vertical reaction. Now this you have to resolve FAC cos 30, FAC sin 30. This is what it. Yeah, now some of the force x direction 0, some of the force y direction 0. In y direction, this is vertical reaction, this is the downward FAC sin 30. This is equal to this. That is what is the one equation. Fx 0, Fy 0. Whereas Fx 0 is, this is one force, FAC cos 30 second force. That is what FAB plus FAC cos 30. Now if you can move other side, FAB, you got a negative. That means your assumed direction is not correct. You have to change like that, you decide this member is a tensile or compressive. Okay, this is how generally we will consider. From once we know the FAC, that FAC upward force, downward force, RA is equal to FAC sin 30. Then the sin 30, RA divided by sin 30 will get FAC. This force in the member. Like that you will get FAB and FAC. Two equations, two unknowns. You can solve. See, this is a concept you have to repeat for other joints also. This joint and by this time this force you already determined. Like that you go on and try to analyze the truss. Now let us consider, this is again, this truss is a simply supported condition, one hinge joint, one roller, and this truss is a perfect truss. Such a type of one truss subjected with a load. It is something like a simply supported, two supports, roller supporting, but load is acting axial. Earlier the load is vertical. See, the directional load can be anything. Here the load is horizontal. This is also a perfect truss if you can see otherwise. 1, 2, 3, 4, 5, 6, 7, 8 like that. If you can substitute, find out the members, you will get, it will satisfy. See now, because it is vertical loads only, no horizontal loads, that is one roller, one hinge, there is no significance of horizontal load. See, in that I am considering a small part, one triangle. Now consider the joint B. This is the joint B considering. This is I am assuming a tension and towards this I am assuming compression. Tensile member, compressive member. First determine the reactions, vertical reactions. 5 newtons, 5 newtons. This is the case. Total 10, 5 and 5 here. And determine this FAB and whereas in this case joint B is given and find out two equations, two unknown. And for horizontal load is applied. Suppose if you can see horizontal force 0. This is the horizontal force. And there is no for this is vertical. This won't contribute. This FBC cos 45, FBC sin 45. Because this is positive and this is opposite, it is acting negative. From this FBC you got 7. Once you got FBC, then a vertical reaction FNA minus FBC cos 45 is equal to 0. From that determined it. Yeah. If it is a positive, your assumed direction is correct. If it is negative means it is you have to make it that is a type of member, what whether it is a tensile or a compressive, you have to decide. So this is how the method of joints is applied. Similarly, we can try method of joints for this type of the truss. Suppose if you can see here, 1, 2, 3, 4, 5, 6, 7, 8 joints are there. Once again, I am counting 1, 2, 3, 4, 5, 6, 7, 8, 9 joints are there. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8 joints are there. Your equation is 2J minus R. R is 3 reactions. 2J is 2 into 8, 16. 16 minus 3, 13. That is the right hand side. See the left hand side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. See, that has to satisfy if it is a perfect truss. Then you will get everything in a determinate manner. See, now similarly the same in this case, only one part if you can consider, some part. This is how, this is a stable, this is an unstable. Okay, now by joint if you can consider like this, draw free body diagrams and try to get the solution. That is what we adopt in the method of joints. Now let us consider, with this the introduction part is over. Now let us consider some of the problems. Here, a truss consists of, let us see first how many joints here and members. If you can consider, this is also considered one member because it is a pin joint I am assuming. One member, 2, 3, 4, 5, 6, 7. Number of joints are 1, 2, 3, 4, 5. Your 2J minus R 3 reactions, assume roller and hinge, or even whatever the form you are using. 3 reactions or 2J minus 3. The 3 is fixed. Okay, J is a 5 joints, 2J, 2 into J, 2 into 5, 10 minus 3, 7. There are 7 members. 1, 2, 3, 4, 5, 6. It is a perfect truss. So now what we have to do is, you draw a free body diagram. This is the final representation of trusses. This is 40 newtons, loads at the joints only satisfied. Now when you are starting from here, no need of reactions, you can start directly. See, that's why if you can start here, the free body diagram is, this is 3 meters, this is 3 meters length. This is BDC. Load is acting downwards, 40 kilonewtons. Now this is a joint, you can start method of joints. This is what? This is how we will consider. This is the load applied. Now from this tan theta is equal to 3 by 3 tan theta is opposite side by inside 1. It is a theta is 45 degrees. Now I am considering 1 and 2 members, 40 newtons downwards. You can assume any direction. This is S1 and this is S2. S1, S2. I start with some assumption. I am assuming it is one is a tensile, another is a compressive. Toward joint, another is away from the joint. Okay. That is what, away from the joint, toward joint. Now this is I am calling as S1, this is S2. S1 is equal to S2 cos 40, S2 cos 45. There is no horizontal, only this is the direction only represented. Only vertical load is acting. S1 is equal to S2 cos 40. And S2, from this S1 is 40 kilonewtons, we will get, because Vertical is S2 sine 45 is equal to 40, upwards, downwards. That's why from this you will get S2, that S2 if you can substitute here, you will get S1. The SU, we got a positive values only, both. That means the SUM direction is correct. When the member is represented like this, it is called a tension. When I represent it like this, it is a compress. That is increasing length and decreasing length. That is what you can follow any convention, but this is the standard convention. With reference to this joint, if this is towards away from, and here also towards, because equal and opposite and now. Here also equal and opposite. That's why when I am joint is this, the assumed direction is correct. If I represent it like this, with respect to a center point, it is increasing length. With respect to the center point, it is decreasing. That's why it is a compressive and it is a tensile. The assumed directions are correct. Okay? Because I got both are positive values. But it is a represented as compressive and it is represented as a tensile. Similarly, one joint is over C. Then go to the joint D. By this time, this is known to you. If you see this joint, the force along DB, the force along ED, and the force along CD. But CD and force BCB, that is S1 and S2 is already determined. As far this joint is concerned, now S3, S4. If we can get this is also unknown, 3 unknowns. 2 equations, Fx0, Fy0, we cannot solve. That's why you see in such a way you have to select. Suppose if you, once I am completing this joint, if I can go joint B. Force along this member, force along this member, force along this member. By this time I know this force, the 3 unknowns, 2 equations we cannot solve as per this joint distance. That's why you have to go for joint D. Then if you can go for joint B, by this time this value is known to you, only 2 unknowns. See like this, can start now joint D. This is already known magnitude and direction. Now I am assuming 2. This I am assuming as a tensile and this I am assuming compressive. I am starting toward joint and away from the joint. This is S3, this is S4. S1 is already known. See that's what is the, see S3, S4 and S1. This is the load act. Now it is simple, no resolution of the forces. S4 is equal to S1, S4 is equal to S1, S3 is equal to 40. That's all. Directly we got. Again, assumed direction is correct. S3 is tension and S4 is compression. See, this is how we will try to represent the trusses, the part of the trusses what we are considering. Then go to the joint B, where now by this time we got to, this is one known and this is known, these are the unknown quantities, 2 unknowns, 2. You assume any direction, try to find out the. See, this is how generally we will try to analyze the system. Here also, the vertical 0, in that you have to resolve the forces, and S5 cos 45, S2 cos 45, plus S3. These 2 minus and this plus S3 is equal to 0, one equation. Horizontal equation is S6 plus S5 cos 45, S3 don't come into the picture, S2 cos sin 45. You resolve this C. S5 cos 45, S5 cos 45 plus, this is away, S2, sigma vertical, it is not horizontal. Vertical means S3 plus S2 cos 45 are in one direction, and S5 sin 45 is in a vertical direction. That is negative. One is up. Then from this, what is the unknown? Unknown is S5. You will get. See, then you will get the S6. By resolving the R. See, this is how we will apply the method of joints, and we can represent the tension or the terms. Joint by joint, you resolve the forces. Finally, you can represent the truss, whatever you got, a tension or a compression or a compression or a tension, tension, compression, compression, tension, with center away from, towards center, compression, tension, compression, tension, tension. Like that we can represent. This is again away from the joint compression. What toward joint? For how we are considering the problem. See, like this we try to represent. Now go to the next another simple problem. Note down the problem otherwise. Determine the forces in all members. Determine the forces in all members of the truss shown in figure. Of the truss shown in figure. And indicate the magnitude and nature of the forces. Indicate the magnitude, nature of forces. There is a tensile or a compressor. The diagram of a given truss. All inclinations are at 60 degrees, which is equilateral triangles. To horizontal, and the length of each member is 2 meters. Length of each member is 2 meters. Sides are equal, angles are equal, all are equal at triangle. Now we can, first we are concentrating method of joints only. Determine the forces in all the members of the truss shown in figure. This is actually final diagram given for understanding purpose. This is the final diagram. Now see the two external, these are the truss or a frame because it is loads acting at the joints, which are truss only. The structure consists of a truss nature. The load, these are the external loads, 3 loads, 40 newtons, 50 kilonewtons, 60 kilonewtons, 40 kilonewtons. This is the hinge joint and this is the roller joint, RA and RD. The distance are 2 meters. All our angle inclinations are 60. This is also 60, 60, 60, 60, 60, 60. From vertical it is 30, 30 because total summation is 180 degrees. Now 3 unknowns, RA, RX, RAY, RAX, RD. But there is no horizontal force here as a total system, vertical loads only. Then vertical reaction. RAX there is no significance. Even if you can consider, you will get 0. That will, sanity is there, momentum of about any point, if you take RAX 0 will get. Now RA and RD, the total upward force are RA plus RD, 40 plus 50 plus 60, external loads. These are the active forces and these are the reactive forces. Now 150 is equal to RA plus RD. About this point or about this point you take moment. One more equation you will get. Sigma fx 0. Fx 0 means only Rax. That is equal to 0. That equation is also valid, but it is indirectly Rax is 0. This is only Ray. R I am calling it only Ra and Rd. You find out the reactions equally. Moment about A0, Rd. Now resolving all the forces in vertical direction, you will get solve the two equations. You will get Ra is equal to, it is equally, we have to distribute. 150 becomes not equal. This is the Rd and this is Ra. But total is 150. Now let us consider joint A. See, this is the choice is yours. I have shown why I have given 2 directions finally, but I confine to this. Initially you can start anything, the choice is yours. But the blur one is final direction. Okay, S1 and S2. And these are the reactions. By this time it is known quantity. Now unknowns are S1 and S2. Because this is the magnitude and direction. This is the magnitude and direction. The direction is known, direction is known. Only the magnitudes are unknown. And this is magnitude is known, direction is known. The total two unknowns, two equations. Sigma fx 0, sigma fy 0. See, that's why here RA is equal to S1 sin 60. S1 sin 60. Now find out S1. RA is already determined. This minus sin 60 will get this. Assume direction is correct. Then you can consider the compression. Then sigma horizontal here. Horizontal. S2 is equal to S1 cos. The assumed direction is correct. See, now if we are considering this here, this is a tension, this is a compressor, obviously it is a tension. Towards this, the member is, let us say, both ends it is increasing. That is what is the mean. With respect to the center, it is increasing. If I can say with respect to center, it is decreasing. That's why it is a compression and it is a tension. Now if we can go to the previous figure, we started this. This is known and this is known. This is compressive and this is a tension. With respect to center, increasing. With respect to center, decreasing. Now let us go to this joint or this. First let us go to E. When you are going E, this is known because equal and opposite. Whatever is there, you have to apply in opposite direction because this is already fixed magnitude direction. That's why as per Newton's third law, equal and opposite internal force. So now what we have to do, from this point, this is known to you. This is unknown. You can consider either towards joint E or away from the joint E. The choice is yours. This is unknown, this is unknown. Three unknowns. Directions are known, magnitude is unknown. We can apply sigma fx 0, fy 0, but we cannot apply moment 0. See, that's why only two unknowns should be there, but three unknowns. That's why we cannot go after joint A to joint E. Now what we have to do is, we have to apply that joint B now. If you are considering joint B, this is known, this is S4 unknown, S3 unknown. This is given. Only two direction is known, S4. This direction is known, this magnitude direction is known, this magnitude direction is known. Now two unknowns, two equations. We can try to solve the problem. See, this is how generally we come across the method of joints. Now let us go to the joint B. This is the joint B. Vertical S1 is already, we decided, it is a tensile member. S1 cos 60, S1 sin 60. We resolve toward joint. This is the direction, this is the direction. Now I am assuming S4 with respect to center, tensile. S3 with respect to the center, it is compressive. I am assuming it is compressive, it is tensile. Now resolve the forces. Sigma vertical 0. Vertical means 40 kilonewtons plus S1 sin 60 plus S3 sin 60. S1 sin 60. Now this is upwards. This is downward, this is downward. These two positive. 40 plus S3 cos 60. This is 60. S3 cos 60 plus 40. And S1 sin 60 upwards. This is left hand side. If you can resolve, by this time S1 is known to you, you determine S3. Assumed direction is correct, you can make tension. Now horizontal 0. Horizontal consists of, this is one force, this is another force. S3 cos 60 resolved. S4 is already there. S3 plus S4 is equal, this is toward the, this S1 also resolve S1 cos 60. S1 cos 60, S3 cos 60 is in one direction, S4 is in opposite. That's why S4 is equal to S1 cos 60, S3 cos. From this find out the assumed direction is correct. So that's why S4 and this one you consider. Now go to the joint C. This is the joint C. In joint C, if you can go to here, joint C, joint E and E, go to here. By this time, this is known to you. This is unknown, this is unknown. Two unknowns. Or you can go to joint E. These two are known, these two can be determined. See, like that we have to go one by one, find out the solution. Okay. So this is the general analogy which we are adapting the method of joint to solve the problems. So now go to the method of sections. Method of section. This is where the procedure is same, but here if you want the lengthy trusses are there. Where if you want to determine the truss in each member, it is also a perfect truss. And we are applying this, please see the statically determinant system. But here it will as truss is very lengthy. If you want to determine only force along the member, then what we have to do is we can analyze the trusses in which forces are only few members are required. In method of joint, you have to start with one by one and do the analysis. It is laborious. That's why wherever there is the required, that particular point you can consider one section. Okay. By considering each section should be an equal care under the force, external forces into moments, etc. Now let us see. This is the truss. What we are considering. Determine the forces in the members. Only FH, HG, GA. I need only three forces. This. See, in that case, I need only one section here. Because three unknowns, I can easily determine. Three magnitudes of the members. Directions are known to you. First, determine the external forces because they are unknown by giving these are the reactive forces by considering the external forces. Number of concentrated loads at the joints are given. If you apply other than joint, it is a frame. That's why I am considering a truss combination only. Because three unknowns at a time I can solve in a plane truss. Because sigma Fx0, Fy0, moment 0, three unknowns are there. Three equations are there, we can easily solve. Now let us see here. I am considering this section. Compare with this is a small length, members wise. Now I am considering left part here. These are the vertical reactions which I already got by considering equal loads. This is total 70. It is a symmetrical truss. We will get here 35 and here 35. Symmetry. Now 35 is applied here. These are the three loads 1, 2, 3, D, D, E, B, D, F. And this is the section. What we have considered 1, 1. Force along FH, force along G, H, force along GI. Okay, three unknowns, three equal. Now what we have to do is summation of moment about G0. This is one equation we got. From this, we can determine, because when you are taking moment about this point, two unknowns are nullified. This unknown directly will get. This into the perpendicular distance, this force into perpendicular distance. This force into perpendicular distance, this into perpendicular distance, this into perpendicular. All are known quantities, only unknown is FH. FH is directly we got by taking moments. See, that's how we have selected. Then FH we can determine by keeping these two. By neglecting such a way I selected a moment. If I can select moment about this point, two unknowns are coming. There is also nothing wrong. But in a gate examination point of other cases, even in examination also you have to save the time, conventional examination. Time is very, very important. That is the reason why you have to see that now this is one equation, we got one unknown. Now use your summation of the forces. vertical forces. The vertical forces are 1, 2, 3. This is the horizontal force. This is the horizontal force. Only vertical will give this value. This is FGH. If this is the angle is given, FGH sine this. This 3 plus this, if you can equate, GH, 3 loads, GH. So this we got the 35 minus 30, and this is the actually a negative value. That's why it is a compress. Here negative I have not given, but put as a compress. Because when you are moving this into right hand side, it is a positive one. But assumed direction is a compress. Assumed direction is this is what we have considered. Similarly, resolving the forces FGI at the this is the vertical horizontal force, this is the vertical force. From that we will get the other force. This is how the method of sections can be applied. This is very simple as compared with the method of joints, but the condition is when you need a particular force in the member, a particular force is required, this method is far better than the other methods. Now go to the second problem. So this is again using a method of sections, determine the axial forces in the members 1, 2, 3. In sections such a way that you select 3 unknowns. Section you have to select. Cannot be more than 3 unknowns. Okay. Here you can take any part, this part or this part. The choice is yours. Now this is S3, S2 and S1. Assume any direction. Here all are taken away from the joints. Now if I can take moment about this point, these two can be neglected and we'll get directly this value. This into perpendicular distance and this into perpendicular distance. P into this height, moment about T equal to 0. And this into this length. Then we can get to S1 into A is equal to P into H. This is from this you will get S1. S1 assumed direction is correct. Compared with earlier, here I am using another notation because away from the joint I am calling as the tension. Earlier representing the choice is yours, how we are representing the notation. That's why I am using both. Now some of the moment about E0 and some of the any equation, some of the fx0, fy0, this is fx0. One translation, two rotation. You like the two translation fx0, fy0 because here if you can see this particular member, it consists of one horizontal load and these members are vertical loads. And this is the inclined load. That is along the member horizontal only, but that you resolve in the x direction and the y direction. So this is how we will try to get the method of the sections also and find out the unknowns. So like this we can determine the any members. Now let us consider this is the one more problem, last problem by using method of sections. Because if I can select, I need S1, S2, S3. If you take this joint, find out these two, then you go to this joint or this joint, find out this member. Like that you have to go. Instead of that, directly you take a section. Now this is the external load P, this is the external load P. Now S1, S2, S3. This is making an angle 30 degrees from the horizontal. Total 60. That is assumed is equivalent triangle. S2, S3, A, C, B. A, C and B. Moment about B0. Because if you take moment, two forces can neglect. Moment about B0, all the three are, this is also 0 external force, but this moment is there. S3 into perpendicular distance this length, S3 into this length BC. From a triangle we got BC is equal to tan 30. This tan 30 is equal to, we determine the expression. If this is 30, this is also 30. Tan 30 is equal to BC minus this A. BC minus AC. Now tan 30, the BC is equal to A. This is not A, this is D, let us say D. A, B, C, D. DC it is. DC means A. BC by DC, DC is A, tan 30, BC is equal to A times tan 30. That value is substituted. This S3 into the perpendicular, the P into perpendicular distance, moment about this point. P into A clockwise. This S3, what is the direction you are using? S3 into 0.3. This is also used towards the joint C. Then only we will get a positive. From this S3 we got negative sign indicate that the direction is opposite its compressive nature. Assumed direction is like this, but that is we got negative, then you have to change it is, then we get a compressive attachment. See, accordingly we have to consider the S1, then you can go to the other two. You have to find out the resolving Fy0, resolving the Fx0. Suppose Fy0 is this point of time, at this point. S1 vertical, S1 sin 30, this is upwards and this is downwards. S1 sin 30, S2 sin 30. No other loads are at vertical direction. Both are opposite. P is also there. The total, because this is the S130 and then total I am considering, this entire part, not a joint, this entire part we are considering. If a joint is, there is no external, but the total part consists of the horizontal vertical force are, this is this component and these two, 2P. These two downwards, it is upwards and it is downwards. 2P plus S2 sin 30 is equal to S1 sin 30. That is the equation. 2P plus S2 sin 30. As from that, P is known quantity, and by this time S2 is known, and S1 you can, whatever known, you substitute, and then Fx0. In Fx0, we will get these are the two components and this is one component. S3 plus S2 plus S1. S1 cos 30, S2 cos 30 plus S3. S3 by this time is a known quantity. S1 cos 30, S2 cos 30 plus from this find out the value of this. Negative sign again we got. See, now you can get S1, two unknowns, two equations. See, like this we can apply the method of sections. But once again I am clarifying here, method of joints is laborious, but if you need an internal force in all members of the structure. Whereas method of sections is useful when you need a specific members values. Okay. Now this is another problem, not entire problem is solved, only the tips are given. Considering the, anytime see, let us consider the joint consists of 3 only. 1, 2, 3, 1, 2, 3. Considering this section, you see this is 1/4, this is the second fourth, this is the third fourth, S1, S2, this. But here I am taking a section in such a way that force in this member, force in this member, and force, 3 unknowns, 3 forces, 3 unknowns. And find out by vertical, you know the values. From that find out theta value, this by this. This is 1.5 and this is the length is 3. 1.5 by 3, tan theta. This is tan theta, 1.5. quarter length half. That is theta, we get the value. Then resolve the force in y direction 0, resolve the force in x direction moment. You find out the values. Okay. Similarly, the second joint. I have not given the entire figure here, only simply repeat the same thing. Similarly, the other. This you can solve as an assignment. To try, if you have any questions, you can ask tomorrow. Here the problem is the truss, simple truss. The A, B, C, 3 meters length, this is 3 meter, this is 3 meter, equal triangles. This is 60 degrees, 60 degrees, 60 degrees. And here also one more member is there, 60 degrees, 60 degrees. Totally the equal triangle. Again this vertical member, and by using method of joints, find out the trusses in all members. Assume that P is equal to 30 kilonewtons. P is equal to 30 kilonewtons. This problem please try at home, and if you have any queries, we will discuss regarding this problem. So now this is what is the today presentation, but I will show some more problems. Let us take some more assignment here. It is available even in NPTEL also, if anybody can refer. The truss, this is a stable or unstable. By using the condition 2j minus 3, these are the questions generally sometimes is asking in the objective gate examination. This is easy member, is the tension approximately, you have to find out by applying a method of sections. If I can take a section like this, the force along this member, force along this member, force. There are 3 forces and 3 unknowns. We can find out. The force along the member EC. If I need a method of section, this load, vertical load, one load is given. This is the hinge joint and this is the roller joint. The same philosophy here. And check the other ones. Out of the 4, which is correct? The objective question means they may ask like this. They will give 4, which what are the correct answers? Multiple answers sometimes. So now this is the truss given. Find out the value. This is C. The joints. This is a horizontal and this is an inclined. But only vertical reaction. Wherever it is there, this is R is a vertical reaction, perpendicular to this. That if you need any, if you are taking this is x-axis, this is y-axis, resolve like that. If you are taking along this perpendicular, then on it. For that, he has given a reference. This is another type of truss. System, a force of 50 kilonewtons is applied at point I, and is asking what is the value of the force in FD, this one. Okay, if that is the case, you can take section like this and obtain what are the forces. No need of reactive force if you take a left part. And so the left part, this is the section. Find out directly what is the force along the ground. Like that, if in the gate, this method of sections apply, this type of structure is better. The same question by asking another members. See, now it is a beam problem to sort of get the reactions. So this is another. If such a lengthy structure is given in a gate examination or even a conventional examination also it will take a lot of time. That's why they don't ask to determine the stresses in each member. Generally what they will ask is you have to find out what is the force along each member, a particular member. Each member is a laborious exercise. Now what we have to do is a particular member, what is the stress. In that case, first find out the reactions and then try to solve the problem. This is one, that is what is the solutions also. This NPTEL is available. If anybody want, you can go through. This is the stability to decide. This is what the equation. For the 2j minus 3, number of joints in the first case for truss A and truss B. This is the truss A and B. Okay. 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. One more number is okay. This is how you have to find out. It is the method of joints. A truss is given. Three kilonewtons, collar support, hinge support. Now this joint, two unknowns. After completing this, if you go to this joint, three unknowns. If you go to this joint, only two unknowns. Okay. That is how we can start joint by joint. First joint B, BA towards away from the joint, BC away from the joint. Now two unknowns. BA cos BA sin 30 is equal to 3, BA sin 30 plus 3 is equal to 0. We will get BA is equal to minus 6. We'll add towards the joint B. I have taken away, but I got a negative value towards joint. Okay, that is how we have to determine. Where the BC plus BA cos 30. BC plus BA cos, because I already changed the direction towards joint. We assumed like this, I got a negative value changed. So that's why BC is equal to, now in that case, BA minus BC or BC is equal to BA cos 30. One is opposite to the other, find out the BC. Use the tensor. So like that we can find out. Once you got joint B, then go to joint A, this joint. Force along this member, force along this member, force along this. Three forces. BA like this. These are the angles, the AC, BA, and now resolve the forces. Summation of horizontal force. Horizontal means BA sin 60, minus AD sin 60, both are acting is equal to 0. Okay. Now if we can resolve AD 6 kilonewtons. Similarly FY, AC minus 26 vertical forces. Only the AC is there. Now resolve the other things. Like that we can get the. Now similarly go to the other joint. Joint 3 means this one. By this time these two are known. And these two are unknowns. That's why by considering joint C, you can resolve the again horizontal force, vertical force, and then see what directions are there. These are the other answers. This is a method of insert joint I up subtract these two. After this, if you go to this joint, three unknowns are there. If you consider this joint, only two unknowns are there. The two unknowns can be solved. Okay, from this. This is the hinge of support and this is the roll of support. Okay, this is a beam problem. See, this is what the trusses which we are considering in the today's class. My dear students, here today what we have discussed mainly, one is the concept of what is the difference between a truss and frame. Once again I am repeating. And also we have discussed the difference between the other two structural members, bar, beam. Bar is one dimensional, truss is one dimensional, beam and frames are two and three dimensional. That is the first thing which we have clarified. What are the learning outcomes are these structures which we can use in a real life scenario in so many applications where we can consider the analysis part is method of joints, method of sections and funicular polygon, where we can use the graphical methods. That is from the examination point of view, from gate and other examination point of view, for funicular polygons, graphical methods. So only two analytical methods we are using, method of sections or method of joints. Then the next, the difference between the frames and trusses. When there is a perfect frame or a redundant frame or a deficient frame, which we have analyzed by considering an equation, members is equal to 2 times joints minus reaction. Our reaction is to pan stress, it is 3. See that how the equation is considered. Then afterwards we have considered some problems related to method of joints and method of sections. First, when you have to determine the method of joints, one important point is you have to select in such a way that at each joint the maximum number of unknowns are only 2. Any two magnitudes of only, or one magnitude, one direction. The choice is yours, but most of times you will come across 2 magnitudes only at each joint. In such a way, you have to select joint by joint, then go to the final. Whereas method of sections, we have done some problems where a particular member is required. In that case, consider a section and see that what is the force along the member. So this is what we have discussed today. And tomorrow we will try to concentrate. The 2 more concepts are left in the statics part. One is principle of virtual work. The second one is center of mass or the center of gravity to calculate moment of inertia, area moment of inertia or mass moment of inertia. We used this concept. We used some of these parameters, center of mass and center of gravity. So these are the 2 issues are left in the statics part. See, once again, if you have any queries regarding any doubts, any clarification, please send your Google Forms and what are the problems I given. Please try at home and come for tomorrow class or send a Google form, or other than this, if you have any queries. And if time permits, at the last 2-3 classes, we will try to solve some more problems by covering all topics of the engineering mechanics. So this is how we will try to solve the structural members. Today we have considered the plane trusses and frames. Bar and beam problems are that is very simple. You already done your strength of material, but here as a rigid structure and engineering mechanics problem, you may ask why we have to go for internal stress. By considering a rigid structure only, we are not allowing any deformation. The same problem we can solve strength of materials by considering deformations. But here the internal force, due to that tendency, there is a deformation takes place. But what is the amount of force is coming? With that, the system is in equilibrium or not. With that we are changing. Why? Because if entire truss is in equilibrium, the joint is also in equilibrium. Okay. Whether when you are considering a joint, the force along the member is required. When you are considering along entire truss, only the actional force, internal force is sufficient to check the equilibrium. But if you check the joint is also in equilibrium or not, that is required. That's why we are considering this problem under mechanics also. Otherwise, if it is only the deformation, this is only the case of the strength of material problem. That's why sometimes in strength of materials also, especially mostly civil and mechanical engineering students, they will discuss the trusses also, not only the mechanics. Okay. So finally, today what I can conclude, the structural members are bar, beam, truss, frame, plate, shell, and etc. But in today, we have considered only 2 structural members, that is truss and frame. And once again, I am repeating, truss is a one-dimensional, but it resolve in 2-dimensional and 3-dimensional in a global axis. Here, loads are always acting at the joints, whereas a frame is, it is a 2D or a 3D, no question of one-dimensional frame. And here you can resolve the loads, not only joints, loads applying it other than the joints also. This is the fundamental difference between the truss and frame. Those are the 2 topics we have covered today. See, that is what is the learning outcomes today. Once again, you have to apply, determine the frames consists of method of sections, method of joints. We can use frames and trusses both and try to solve the problem. Okay. The method of sections is always better from the gate and other examination point of view, where we need a truss in a particular. Once again, have a good Sunday. If you have any questions, please pass on to Google Forms. Enjoy the Sunday. Best of luck. Thank you very much.